All right, so this is going to be our last data point collection, and it is going to be our 40 minutes data point collection. And as you recall, we did finish out the small cubes last time. We finished out the big, flat, different shape a long time ago at 10 minutes. And so the last one we're waiting on is the big cube. And we're not actually going to wait until it finishes all the way. But as you can see, originally compared to its entire pink shape, we now are left with this tiny little section in the middle that remains pink. So we're going to find out what our diffusion depth is right now. And right now, just to kind of see all the sides, compare them. Our diffusion depth is about 10 millimeters, right, on average. Some of the sides are a little less, some of the sides are a little bit more based on the shape, but our diffusion depth is about 10 millimeters from both sides. That means that the actual distance, right, if you go 30 in total and you go 10 in from the right and 10 in from the left, the actual distance left of the base of the pink is only 10. So for our last row of calculations that I, as an error, didn't leave room for, we're going to have our 40 minutes in our data table, and then we're going to have our 10 millimeter diffusion depth, and you're going to use that to calculate out the volume of pink left in the big cube. You're going to use that to calculate the volume of white that has been growing the whole time in the big cube. And remember, you're done with the tables for the other two a long time ago. Now, that being said, once you actually finish with these data tables and your calculations, your data collection, I'm going to need you to go ahead and get ready to graph for me. Okay, remember, again, the graph setup is going to be the linear distance diffused, aka the distance of the white. Okay, so we should have axis labeled with time, right, because it says versus time here. And then this one is going to be the distance in millimeters, right? Distance of diffusion in millimeters. Over here, we're going to have volume diffused versus time. Actually, you're kind of lucky. I gave you the titles on these already. So volume diffused versus time. So this is going to be time as the x-axis. And then y is basically going to be volume diffused, or if you want to rephrase, the volume of white that you calculated right here. Okay. You're going to be graphing. So I need a key on the side for both of these because you have 3 to graph, right? You have one line for the big cube, one line for the small cube, and one line for the different shape. And you have multiple time points. So make sure you connect your dots. So if you have 0 to 10 to 20 to 30 to 40, you got to connect all of those dots after you make them. And make sure that if you don't have different colors, you can just use different shaped dots like stars or circles or squares. And if you don't have those, then you can use different colors. Sorry, if you have different colors, you can use the colors, but make sure you write a key on the side for which one the big cube is represented by, which one the small cube is represented by, and which one the flat shape is represented by. After you do your graphs again, go ahead and answer these questions. You can pause to look at them, and that will be your entire report that you are submitting for me, and it is one of your last grades for this grading period.